And so parts per million are a good way of telling you how much of something is in the water, and it's a good way to like use an index. Volume is good if you just happen to be using something like hydrogen peroxide. But if you're actually doing chemical reactions, you need to know how many molecules are present in a solution, for example. And so usually in chemistry, we use things like moles per liter so that we know exactly how many molecules there are in that solution, and everything is proportional. And so in this case, we're actually going to take a gram weight of something, we're going to add it to a volume, and the question is, what's the final molar concentration of copper sulfate? And so molar concentration is the number of moles divided by the volume in liters. We have the number of grams up here, and what we want to do is convert this into the number of moles. We have a volume in milliliters, but we can quickly convert that into the volume in liters. Okay. If you add up the mass of a copper atom, a sulfur atom, and 4 oxygen atoms, you'll come up with the molar mass of copper sulfate. And 1 mole of copper sulfate has a mass of 159.6 grams. And so we are actually going to find out how many moles we are by going using our factor label method. 5 grams of copper sulfate. 5 grams of copper sulfate times our conversion factor. And as you can see, I have significantly less than 1 mole. So I'm just going to find my chalk-covered calculator. So 5 divided by 159.6 is 0.031. And I'm going to carry another decimal place, 313 moles. Copper sulfate. And you can see that the grams of copper sulfate here cancel with the grams of copper sulfate there. And I wind up with moles of copper sulfate in the end. Now I just need to put this into my concentration equation. And so concentration is equal to 0.0313 moles copper sulfate. And we have 0.25 liters. So when I divide that point by 2.5, I get 0.125 mole per liter copper sulfate.